that most of today's software is much like an Egyptian pyramid, with millions of bricks stacked on top of each other, with no structural uh, integrity, but simply made by brute force by thousands of slaves. Yeah, it's 12 p.m. We're on. Yeah, yeah, exactly. The only thing is that we don't do daylight saving times. Yeah, but so there's a little bit of the year where we're an hour off, but we're on the same time zone. Yeah, yeah. I think that ideas are like a fragile thing. If you stop talking about them, and all of a sudden they disappear. So it's important to like sync up and pick each other's brain to see what are the important ideas that are worth like repeating and going over and enforcing. Yeah, of course. We need to strategize and do a little bit of like divide it up, and each of us takes a different section. Exactly, and we can do like a private wiki, and we just perfect. Is my audio okay? Excellent, awesome. So let me get through the protocol initial. Who am I? Essentially, I am a software architect. I created a method called grep, and obviously went to MIT. I've worked with a lot of clients in a lot of different areas, like entertainment industry, the government. Here, I'm based in the Dominican Republic. Private sector, everything from laboratories to museums that want to do art exhibits. So essentially, people call me when they want me to fix a technology issue they're having, and my definition of technology is quite broad, since it goes from maybe a legislature they want to pass to some coding or an architecture. So I wanted to thank Bapa for the opportunity to share these ideas. Like I said before we started, I think that ideas are a fragile thing, and if you don't protect them and repeat them, all of a sudden they disappear. And when I was thinking about what I wanted to talk about, obviously you're extremely influenced by what you do on your day-to-day basis. And lately I've been doing a lot of consulting, and I've been talking to a lot of CEOs and business owners about what they want to do. And it's an interesting time. And I want to start with pyramid analogy. And this pyramid analogy actually comes, I'm stealing it from Alan Kay. And he goes around and says that most of today's software is much like an Egyptian pyramid, with millions of bricks stacked on top of each other, with no structural integrity, but simply made by brute force by thousands of slaves. And it's a crude analogy for a software development, but the truth is that up to very recently, the strategy had been based off of that. A lot of building blocks that don't really talk to each other, and they build what they can build. And the reason why the pyramids are the shape they are is because that's the only shape they can be. The idea being that if you start to stack any type of bricks up over time, they will fall into a pyramid. That's the only structure that supports that. And although it's very stable, it's not a very efficient structure. And that leads to inefficient structures all around. So over time, and this is the first thing that I wanted to center or my talk today around, I want to talk about the current state of the industry. Talking about the future is tricky because it's hard to imagine what's going to happen in a year, let alone 15, 20. But the cyclical nature of history provides a wonderful insight into what happens when the paradigm shifts around. And I prepare this graph for the talk, and I wanted to explain a little bit the different periods of how we got here. So this goes from the 60s all the way up to present day. And then there's some projecting trends that I'll turn on in a second. And today's talk is going to be about speculating a little bit about those trends, but I'm going to call it educated speculating based off the patterns that we've seen before and the patterns that I'm seeing in the future. Right now, essentially throughout most of coding history and modern coding history, I'm going to call it since the 60s, if you wanted to build code faster or add functionality, you had to hire more people. That's how it went. There was a linear correlation between how many people you had and the amount of functionality you had. In the 80s, when personal computer blew up and higher level languages started to pop up, that new tool unlocked a new level of productivity. It's very hard to do complex stuff if you don't have objects and an operating system, right? And then in the 90s, you have the operating system taking over, and that also provides a good boost. And I have this blue line, which is functionality, is all of these, let's call it trends, right? I've tried to turn them into a percentage, right? And functionality, and this blue axis is what I call the coding heaven. It's a team where everyone in the team is producing value for the customer. We have fun coding. Every single day you do is not bug fixes. It's just new things that you're adding on improvements. That's what 100% functionality looks like, right? Then 0% functionality is a company that puts out tons of code and nothing works, and we're just on bug fixing hell. And team size is easy to understand. Like 100% is the most engineers you can hire, and 0% is the least engineers you can hire. And complexity, I think, is self-explanatory. But in today's age, the complexity of the system and the complexity of creating the code is also the new factor, right? We understand code complexity, but now there's complexity in how we create the code, which is another added factor into it. So I want to talk about the strengths, and let's go through a little bit of what I think happened in the 2010s. So as you can see, I've tried to illustrate that all the way up to the year 2000, we had functionality going up to peak 70% in 2000. Okay. At that point, something happened, which was that the internet came up. And all of a sudden, we stopped focusing on new functionality and we started focusing on migrating functionality. All of a sudden, we wanted the systems to be interconnected, which is arguably a functionality, but it's not added value to something that was happening locally. And I think there's a very good argument that from the year 2000 all the way up to 2010, apart from all the advancement that happened from having internet and interconnected platforms, we had a very gradual advancement. Nothing was exponential about the way that technology developed, right? Now, since the year 2010, I've been studying this decline in productivity in coding and the functionality of teams. And what I'm seeing is more and more oversized companies that have a lot of engineers and had a lot of engineers until very recently, and let's definitely talk about that. But if we focus on this section, right, what we're seeing is throughout 2015, the complexity keeps going up of what we're doing and the functionality goes down until there's a crossing. And then the size of the team needs to go up in order to keep up with the complexity. Now, what happens when AI kicks in? And it's hard to put a date into all of this, but what happens is that the team size starts to go down and the complexity goes up and the functionality starts to go up again. Because all of a sudden, all the senior engineers that were on the team that couldn't really get all their bug fixes and all the stuff they wanted to do start regaining control. And you don't need to deal with the junior and the mid-level engineer. You have superpowers because the coding structures have been exponentially sped up, and all of a sudden you can do the work of multiple engineers. Now, let's get into the predictions. If I turn this on, here's what I think is going to happen. I think that the team size is going to still go down. I think that we are going to keep the same functionality. And I think that the complexity of trying to interconnect all the code that's being generated in silos is going to still continue to rise. There's this new term called vibe coding. Literally project managers and junior coders that go into an automated IDE and start coding a game, and they just like put it out, or they code an app and they put it out, and how they do it is not really understanding the code, but just asking it and putting it live out there for users to use. And without like just recently, there was a new case of a guy that went bankrupt because they hacked the site that he made on ChatGPT and they started to drain his account. And that's the type of stories that we're going to see when the complexity of this keeps going up and everyone and their own can code based off of that. So the technology and the evolution of these teams is something that we need to understand, and we need to ask ourselves, how does this changes the structure of the business that we've had in a solid structure for a long time. So the technologies that we're investing, what are the challenges in managing those technologies? I'll give you a simple idea. Let's say that you code a chatbot, which it's one of the things that one of the main drivers of this talk is the fact that for the past year, I've been getting phone calls from CEOs and leaders, and every single one of them wants to build a chatbot. And I'm trying to figure out how to explain to them that there's no sense in building a chatbot if you don't have the infrastructure to provide a service. These people don't have databases that are well connected and optimized, or services that are online, and no correlationship between the digital side of their business and the brick and mortar side of their business. And they want to optimize with AI a process that doesn't exist. So this talk wants to drive home the message of we need to, in this time and age, become judo fighters and try to leverage that interest in technology into something productive. Because the challenges that they're going to face and the changes that are going to happen throughout the organization are things that I don't feel we're talking about in the boardrooms. We are going to have to deal with the fact that the team is going to keep downsizing because the cost of it is going to keep rising, the cost of having a coder in-house. And we're going to break the talent pipeline. And what I mean by that is traditionally you go to college, you get hired as a junior engineer, or you go into a training program where you start learning, and then you become, after a few years, a mid-level engineer and finally a senior. Now, the issue is, why would you hire a mid-level or a junior or someone that just graduated out of college when all of that work is being automated? The gap between when universities go and like, universities are not going to want to teach AI up until the last minute, because they're the thing that's going to protect them from becoming obsolete in their minds is going to be, oh no, we're going to teach you how to do it from scratch, right? And then all businesses, like, they're going to jump into the market having like, it's forbidden now to use AI in colleges pretty much for coding. So you go into the field, and the field is demanding people that aren't doing the groundwork, but are actually software architects or project managers, and they need to be good at doing a different set of skills. So the new model, and the new model that we need to communicate to leadership is, hey, we need to start financing creative spaces to account for the missed stages that we killed. And if we don't feed money into that, in 10 years, it's going to happen or in 10 and 20 years, we're going to run into the same issue that the Disney animators had. I come from entertainment, so let me give you an entertainment story. In the 70s, the Disney films, 101 Dalmatians, Cinderella, all of the 2D animated films were done by a team of senior animators called the Nine Old Men. And those were essentially the heads of all the departments at Disney, different departments over the years, initially in animation. What happens in the 70s is that they get old and they realize that they haven't trained anyone. The gap between them and the junior staff is 50 years. And these people are about to retire. And the man with the all white beard decided to build CalArts, which was a university in California just for animation and the development of arts. And they decided to start writing down the knowledge and open up the secret vault of how this was done. Ladies and gentlemen, we're going to jump into a little bit of that era, and we're going to see it. If you're a senior engineer or a CTO in a company, you're going to start to wonder, hey, why don't I do my own startup? And you'll be extremely successful at it because you can put a good product and run it from your home. But that's going to create a silo and a breakage of knowledge if we don't start talking about it. If we don't have an open community, we're going to start to close down, because what's going to be proprietary when anyone can generate code? When you can code your own version of Photoshop or your own version of Word, why would you buy software under this paradigm? And ideas and the way you do things are going to be different. Here's where I'm going to pick up the analogy of the pyramid back up. The cathedral comes in, and what allows a cathedral to be a lot taller than a pyramid is the fact that it has arches. And pyramids and cathedrals are almost completely made out of air. So it's a more efficient structure than the pyramids. And this is what we're running into. We have trends in technology. The cost of programming is going to go down to zero. And then the global competitiveness and the communication with executives is going to be key, because otherwise, if you're lost in the politics of it, someone that's more efficient, that knows how to do it, no longer has the entrance barrier of needing 150 employees to do it. So they're going to take over. So meritocracy is the key word here. I want to talk about WeChat, and this is something that we're going to see, and I want to call it the WeChat paradigm. For anyone that's not familiar with it, WeChat is the biggest app in China. 2011, they launched as a basic messaging app. 2012, they started to expand. These days, WeChat does everything. Baba? Yep. Awesome. Okay, so WeChat success relied on the model of being a super app. And I think this is what's going to happen. With the cost of programming going down to zero, the Western fragmentation, right, which is having WhatsApp for messaging, Instagram to share pictures, PayPal to pay, or Apple Pay, or Google Pay, or Uber for Lyft, that is going to disappear in an interesting way. And I think that what we're going to see is a consolidation trend, where Facebook obviously is the one that's best placed right now to become the WeChat of the world. And what they want to do is integrate WhatsApp, Instagram, and Facebook messages into a single ecosystem. They've started doing that. The big challenge they have in terms of technology is that obviously these were made with completely different tech stacks. But now that the cost of migrating those tech stacks is going to go down significantly to zero, we're going to have super apps. Like, there's no reason why WhatsApp is not going to have its own store, and they're going to add tons of new features. And we're going to get into a little bit more of that Asian market paradigm, not only because it's going to be cheaper to do that, but because if you're Apple, you want to have everyone in the ecosystem. Like, they understood that a long time ago. Now, what happens is that in order to have an app store these days, you need to allow the apps itself to have transactions. And now those apps are going to grow into virtual machines where you can write plugins and run them on top of WhatsApp, on top of Facebook, which it's already something you can do. The limitation on those has been that obviously it's expensive to code a plugin. But now they're going to eventually realize that the business is to provide a platform in which all the code runs, and charge the AI fees, which is the only fees you're going to be able to charge, the processing fees. And then they all want to be WeChat and they all will want to be WeChat. That's a weird tongue twister. The rise of China also is going to make it so that we need those integrated systems. I'll explain why. And this is my big caveat of all this. Obviously, if you are in China or in Russia and you have to give access to the government on everything you do, you tend to build an open system so that the information is easy to retrieve and 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 to integrate things into the platform. The fragmented system that we have, it's not going to be able to compete with an integrated system, because that's the first principle of industrial engineering. You need to reduce variability, and the Western variability on how we have the data is going to kill us, because in Asian markets and they really have their data consolidated, and in Europe they have their data consolidated because of the European Union. Their statistics are far superior to what we have in Latin America, for example, where every country doesn't really share their data in between their models. So the politics versus engineering, and I'll stay here for a second, is the fact that for all intended purposes, we have to deal with the boss's son is leading a department here in the West, and that makes it so that that department is inefficient. Here we have to deal with legislature that doesn't really support the business, and that adds a lot of complexity. Here we need to, we have wages that are higher, we have structures that don't really scale, and now we need to deal with everyone here being able to do it cheaper than us. That democratization of the future of software, I think that is the crossroad, the new role of the CTO. And that's a little bit of where all this comes together. Is the fact that everybody's going to be a little bit of a CTO. And we are talking about what happens when you don't think of a coder as something that a team does, but as something that a person does. And the example that I want to bring is law. Let's say that we don't really think of a contract or law as a piece of technology, but the truth is that we came up with the fact that there's laws. They're a little bit like a magic spell, I always tell my students. But essentially, at the beginning, laws and contracts were something that needed to be done by huge organizations. These days, if you want to get married, you don't really need a law firm for that. You can go to your family lawyer, and in the not so far future, ask ChatGPT to do it. So that's the analogy that I want to use. Like, big teams and units of 50 coders are going to be completely run out of existence. And at that point, the job of a CTO in a mid-sized company will be to open up their control panel and decide, okay, I really wanted to change the website. So let's just open up the website and start changing things on this service. And the danger of doing that is going to be really low. And the success rate of that is going to be really high. So I don't think we're ready to manage companies like at the size they were in the 70s and the 80s, where that's kind of how you operated as a programmer. So this is what I mean by the cyclical nature of, if we go back here and think of what the team size was before and what the team size will be now, the type of things you were doing exponentially as a coder is what's going to happen now, where with small teams, you'll be able to do a lot more, but that increase in complexity is going to make all these systems that are generated extremely hard to manage. the architecture of a system that wasn't designed to be run on AI, it's gonna keep increasing in complexity until it gets to 100%, and the only thing that understands it is machine code. And that's problematic because that gets us into the same issue we coded ourselves into with the microprocessors. On a low level, Intel doesn't really know what the processor is doing because they've optimized so much with AI that there's this hidden layer, and that's gone. That's not coming back. So we're going to build this layer of crap junk software that's going to peak at 60% functionality with these super apps that do everything the same until we understand that we can't keep building pyramids, and we need to start talking about the arc and the new things that we can do with an arc. And that's what I wanted to share today. Baba, did I finish in time for your meeting? Oh, I think he left. Yeah. He just left it open. Hmm. Thank you. I have a lot of the same conversations, and I start to see patterns. And sometimes when you're only focused on a project, and this has happened to me when I was at Netflix, all that I knew was Netflix stuff, and their tech stock. But then for the past 2 years, just going and sitting down with CTOs and just checking their complete tech stack and their problems, it's insane because you go out there and you can't hire anyone. Like kids out there want to do their own thing. They don't want to be a part of the project, and they want to charge, $500,000 a year. In their head, that's how much they need to earn in order to go to a 9 to 5. And I have like DC CTOs trying to ask me, so do we build a chatbot? And I'm like, no, wait. Let's try to figure out first who in your team can be a software architect and a project manager. Because like there's essential questions that if we don't talk about them, it's going to explode in our hands. Yep.